This is one of my favorite kinematics problems, and we can kind of just make up some numbers here. But imagine you have a model rocket, and you launch the model rocket, and it has an acceleration, upward acceleration of 12 meters per second squared. I just made up that number, and the rocket engine lasts for 3 seconds. The question is, how high does it go before it comes back down? So let's just start, right? How high does it go? Well, I think the first thing would say, okay, I can say y equals y0 plus v0t plus 1 half a1t squared. And we'll call this t1, right? a1t1. That's the time it takes to move. And so it's going to start at y equals 0. y0 is equal to 0, and v0 equals 0. And those have units. You know those have units, but I kind of leave those out because I'm kind of space challenged. So can I find out how high it goes? Well, let's just put that in right here. Y is going to be 0, 0, 1 half a1 t1 squared. I know a1, I know t1, I'm done. That's it. That's the end of the problem. Good job. It's not the end. It's not the end of the problem. I can put in my numbers there, but I'm not going to. Because after 3 seconds, it doesn't stop. It's moving up, right? It's moving up and it has some speed, so we actually have to break this into 2 parts. So the first part, it's accelerating up, and it gets to that point right there. That's this. I'm going to call that y1. And then it has a velocity v1, and it keeps going up higher and higher until it gets to the highest velocity, v equals 0 meters per second. And I want to find that distance. So that's my first distance. I need to now find my velocity, which I'm actually going to call, we'll call it v1. Okay. So v1, I can say v1 is v0 plus a1 t1, right? So this is just my normal kinematic equation. I take the initial velocity, which is 0, my acceleration of my time, so I get v1 equals a1 t1. Now that's going to be my initial velocity in the second part of the problem. So in the second part of the problem, let's just solve for it. I'm going to say, second part here, y2 equals y1 plus v1 t2 minus 1 half g t2 squared. That's what I would have to do, right? Because here is my final position. It starts at the position I just found right there with the initial time I found right there. But the t2 is the time it takes to go from here to there. I actually don't know that time. I could find it. I could find that time. I could say v2 equals 0. That's the final velocity, which is v1 plus minus g t2, and I could solve for that. I could solve for t2 and then plug it in up there. But there's also the other kinematic equation that says v2 squared v1 squared minus 2g y2 minus y1. Right? I derived that kinematic equation, and that does not have the time. So in this case, v1 is the velocity at the beginning of that time interval with an acceleration of negative g. y2 is the final height, y1 is the starting height, and I want to solve for y2. So that's what we're going to do. So let me put some of this stuff over here. v1 equals a1 t1, y1 equals 1 half a1 t1 squared. Okay, so let's put in our values here. So my final velocity v2 at the highest point, 0. So I get 0 is v1 squared minus 2g y2 minus y1. I'm going to go ahead and solve this for y2, and then I'll plug in my values. And you could put your numbers in way before this if you wanted to. If that makes you happy, then that's what you should do. Okay. So this is 2g y2 minus y1 equals v1 squared. I'm trying to solve for y2, so I'm going to divide both sides by 2g. y2 minus y1 is v1 squared over 2g. I'm going to add y1 to both sides. y2 is y1 plus v1 squared over 2g. Now I can put in my expression for v1 and y1. So I get y2 equals y1, which is this, 1/2 a1 t1 squared, which is, I gave that t1, I have that a1, plus, I did that a little too close. I feel just, I'm going to start that over. y2 equals y1, which is 1/2 a1 t1 squared, boom, boom. And then I'm going to put in this for v1, so plus that squared, which is a1 squared t1 squared over 2g. Now I can put in my numbers. So y2 is 1/2 times a1, which was 12, t1 is 3 squared, plus 12 squared, 3 squared, over 2 times 9.8. And remember, g is 9.8, not negative 9.8. So let's put in our values there. Calculator. So 0.5, 12, 9, that's 9. And then I have 12 squared. And then I have 9. And then 2. I get 120 meters. Seems reasonable for a rocket. I just made these numbers up. They might not be right or not, but there you go. It's a two-step problem. It's a two-acceleration problem, right? Acceleration, acceleration. The final y here is the initial y for the second part. The final velocity here is the initial velocity for the second part. There you go. Kinematics.